This week's lab is a continuation of Lab 6. In Lab 6 we had a physical representation of our system and took some experimental measurements. This week we will be creating a numerical model of our system. Before we do that, however, we will learn about a new tool that will help us further analyze systems: eigenvalue problems. You may have learned about eigenvalues before in your linear algebra class. In a generic sense, eigenvalue problems are just a way of solving for certain unknowns in a matrix problem of the form A times X equal to lambda times X, where A is a given matrix, X is an unknown column vector called an eigenvector, and the lambda is called the eigenvalue. Getting the eigenvector and eigenvalue of a matrix has several different applications in all the different fields of engineering. But for us, the eigenvalues and eigenvectors can tell us important things about our system. Now the background and activity, we'll go into more detail about that. For now, in this video, let's just concentrate on using MATLAB to solve our eigenvalue problems for us. MATLAB has a function called eig, and it allows us to solve eigenvalue problems with relative ease, requiring only an input matrix and a user-specified output. So let's give it a try. Alright, now first we need an input matrix. Alright, we'll call that A. And we'll set that equal to a square matrix, which will have the value 10, 5, row down, 5, 10. Okay, so let's run that just to see if that looks right. And down here in our command window we can see it looks exactly like we want it to. Alright, so now that we have the input, we need to specify what we want as an output. Alright, since we want the eigenvalue and the eigenvectors, we're going to set our output equal to V, comma, D, where D is the eigenvalue matrix and V will be the eigenvector matrix. Okay, so now we can actually write out the eig command, which is just eig parenthesis A and parenthesis. So let's run the program, and you can see the eigenvector and the eigenvalues. Alright, so if you've already looked through the example problem provided for you on iLearn, you will notice the tremendous amount of time this MATLAB command saves us compared to trying to work it out by hand. Take notice that the example we just did involves only one matrix for your input. In the activities you will work in this week's lab, you will have two inputs, your stiffness and mass matrix. A full breakdown and explanation of how this works is available in the lab background. Now the eig command in MATLAB with two inputs is virtually the same and is also shown in the background. The last portion of the lab has us building a numerical model of a 2-degree of freedom system. This will be very similar to what was done in Lab 5. That means to succeed, you should be comfortable loading in data to MATLAB, building a Simulink model, and then graphing the two responses together simultaneously. Keep in mind, this is a 2-degree freedom system, so the time response data and the Simulink model will look different than what we had seen in Lab 5. Now for an example of the Simulink model, please refer to the picture on the second page of the background.